So the first topic we are going to discuss is Z-Wave. Z-Wave is actually developed by a Danish-American company Zensus in 1999. What actually happened was they're trying to integrate into their products, some intelligence to the RF communication. But when they were working on that, they actually stumbled up in a new idea where they wanted to group all the pros of the existing technologies and create one new technology which has paved the way for Z-Wave. The Zensus is actually a integrated single chip solution company. So that is how they got into the idea of Z-Wave. This slide explains about the protocol layers of Z-Wave. It actually has four important layers plus the application software layer, which is the topmost layer. The lower four layers are RF media, medium access control, layer 2, transfer and routing as their third and the fourth layers. So the Z-Wave characteristics are listed in the slide. They follow mesh topology or the mesh architecture. The efficiency of Z-Wave is because of the routing protocol they use. More than one Z-Wave network can coexist. That is one important feature. And the maximum it can support is 232 nodes in a single net. This slide shows the basic Z-Wave network structure, which is basically the mesh, and every node can communicate with each other through hops. And the most significant point is it is compatible by devices manufactured across different companies, which means they are compatible with one another, which makes Z-Wave successful. Slide which tells about the Z-Wave protocol. So we already saw the layers, which are again replicated here for your easy understanding. So the application software layer is usually contributed by the OEMs, which is the original equipment manufacturers. So it includes application softwares, for example, like thermostat, sensor, door lock, etc. And the routing layer, usually the routing layer protocol is source routing algorithm, which Z-Wave uses, and it also uses any one of the cast methods which are listed here: single cast, multicast, broadcast, and routed single cast. Transfer layer uses the local administrator address scheme with two kinds of IDs, the home ID and the node ID. MAC layer uses short frame size of 20 to 30 bytes while transmitting, and the RF signal uses the frequency of 868.42 megahertz, and in US it is 908, and for error checking it uses checksum model. Slide is a real-time example which helps us to understand how the Z-Wave works. So it is a basic mesh modeling where you can transfer the data via the existing devices by themselves. So here it's a map of a house, layout of a house. So in case you wanted to control the lamp A in the dining room, there are two ways, or maybe it can have more number of ways, but in the slide we have represented two ways. Either you can operate it through the kitchen devices via maybe lamp K, then you control your lamp A, or via the garage devices. So you go to the lamp M, and then via lamp L you go to the lamp A. So if there are any one of the routes which is damaged, then you use an alternate route. So the reason for not able to reach through a particular route may be due to dead spots. So dead spots are something where the device through which you wanted to communicate is under repair or damaged. So it creates an open state, so the communication cannot continue further through that device. Maybe there was a fridge which was helping you to route the information to other devices. Now the fridge is under repair, so that becomes a dead spot. Slide explains about how the Z-Wave addressing scheme works. So as we have already discussed, it has two parts. One is the home ID and the node ID. Home ID is 32 bits and the node ID will be 8 bits. So whenever there's a microcontroller which you deploy in a particular home to automate n number of devices, All the devices connected to the single microcontroller under the home obviously should have a same home ID. Only then they'll be able to communicate with each other. So whenever there's a microcontroller and a new device gets added, that is a device which helps the other devices, other new devices to get added into the same home in case if they wanted to belong to the same home. So when a new device comes, it is assigned a new node ID but the same home ID, so that it becomes a part of a single network. So likewise, whenever there are devices coming up, new node IDs will be given, but if they are part of the same network, they all will share a common home ID. So now there can be two different networks in the same home, but they'll be identified by different home IDs. So each of them know that they exist, but they cannot communicate. One home ID cannot communicate with another home ID, so they are not interoperable. So if at all communication has to happen, it can happen only through the devices which have same home ID, and that's what the slide tries to explain. And the other thing is like the path to be chosen, okay, by the microcontroller to send the signal is only through the devices which have the same home ID. So that is what I was explaining. So you can just have a read through in this slide so that you'll get better understanding. This slide is again not new. It is just a visual representation what the previous slide was explaining. So that's home A and home B. So home A will have a different home ID and the home B will have a different home ID. So whichever nodes have same home ID, they communicate with each other. And in the right side, when you see home B, they have a different home ID, whereas it is 4 sevens and 4 eights. So all of the devices which has this same home ID can communicate with each other. So there are four different numbers given, node ID 0, 1, 2, 3, 4. And similarly under home A, there are four devices which has node ID 0, 1, 2, 3, 4. So it is just a visual representation of what we saw in slide number 11, the previous slide. And this is the slide which tells about the type, which we have already been seeing in different terminologies when it comes to ZigBee or any other technology for that matter. So we were using these terms fully functional device and the reduced functional device. Similarly, here you have three types of archetypes. The first one is controller. The second is a routing unit, which we call routing slaves, and the last endpoint, which is the slave. So looking at the functionality, again it is very clear that the controller will have higher functionality when compared to the routing slave and the normal slave. So that is what this slide explains about. This slide gives us an idea about different type of controller nodes you can think of. There are two types, the portable and the static. It's very vivid from the heading. Portable controllers are one which can move around, and the static controllers cannot move around, and they remain static in a specific place and then contribute in the overall data communication. The other important thing is, in case if you want a Z wave device to communicate with a non-Z wave device, there is still a possibility. So you deploy a device unit called as bridge, which acts as a proxy for this non-Z wave device. So that a non-Z wave device and a Z wave device is capable of communicating with each other. One example which you can think of a non-Z wave can be your Bluetooth network. So in that case, you use a bridge in order to have communication achieved between these different networks. So under the networking node types, we saw controller, and now it is about the routing slave. So routing slave is usually AC powered, and it is mostly fixed in a it's static and fixed in a specific location. It is capable of both receiving and replying from and to other nodes. It also involves an unsolicited, which means voluntarily, without even asking, it is capable of sending the routing information for 5 other nodes. That's the maximum nodes to which it can communicate. And there is an enhanced slave model which is same as routing slave, but then it has some external memory support, which is of type EEPROM. This slide again emphasizes the basic definition of what do you mean by slave node. As we've already seen from the previous slide, this is mostly fixed, point number one. And second is it is always on or listening all the time. It is capable of both receiving and sending reply using the same route.